Welcome back. In the previous lesson, we built one clamper and added one bias source, but there are many more configurations. Today we will work through 5 worked examples that cover every bias combination you will encounter. Here is the key insight. Every clamper has the same skeleton: a series capacitor, a diode, and a load resistor. When the diode turns on, the output is clamped to a fixed level we will call the clamp level. When the diode turns off, the output equals the input plus or minus the capacitor voltage. The clamp level is determined by two things: the diode forward drop, V sub D, and the DC bias voltage, V sub DC. Together they form 4 sign combinations: plus or minus V sub DC, plus or minus V sub D. That gives us 4 biased examples, plus 1 baseline example with no bias at all. 5 examples, 5 different clamp levels, 5 different output positions on the y-axis. Same rule, every time. Peak to peak is preserved at 2 V sub M. Example 3. The baseline case. A silicon diode pointing up, no bias source. Input is a 10-volt peak square wave, swinging from plus 10 to minus 10 volts. When the input is negative, the diode is forward biased. The output is clamped to negative V sub D, that is minus 0.7 volts. While the diode is on, the capacitor charges. V sub C equals V sub M minus V sub D, which is 10 minus 0.7 equals 9.3 volts. When the input swings to plus 10, the diode turns off. The output equals input plus capacitor voltage, 10 plus 9.3 equals plus 19.3 volts. So the output range is from minus 0.7 to plus 19.3 volts. Peak to peak is 20 volts, exactly matching the input. Example 4. Same circuit, but the diode is flipped, pointing down, and we add a 3-volt DC bias in series with the diode, with the positive terminal on the cathode side. Now the diode conducts during the positive half cycle when the input is plus 10. The clamp level becomes plus V sub DC plus V sub D, which is 3 plus 0.7 equals plus 3.7 volts. The capacitor charges to V sub M minus V sub DC minus V sub D, which is 10 minus 3 minus 0.7 equals 6.3 volts. When the input swings to minus 10, the diode turns off. The output drops to input minus capacitor voltage, minus 10 minus 6.3 equals minus 16.3 volts. Output range from minus 16.3 to plus 3.7 volts. Peak to peak 20 preserved. Example 5. The diode points up like example 3, but now we add a 3-volt DC bias with the positive terminal on the anode side, helping the diode turn on. The diode conducts during the negative half cycle. The clamp level is plus V sub DC minus V sub D, which is 3 minus 0.7 equals plus 2.3 volts. The capacitor charges to V sub M plus V sub DC minus V sub D, 10 plus 3 minus 0.7 equals 12.3 volts. During the positive half cycle, the diode turns off. Output equals input plus capacitor voltage, 10 plus 12.3 equals plus 22.3 volts. Look at the result. The output ranges from plus 2.3 to plus 22.3 volts. The entire waveform sits in positive territory. Peak to peak 20 still preserved. Example 6. Now flip the diode to point down again. Bias 5 sub DC is on the ground side, pulling the diode cathode into negative territory. The diode conducts during the positive half cycle, but because of the bias, the clamp level is minus 5 sub DC plus 5 sub D, which is minus 3 plus 0.7 equals minus 2.3 volts. The capacitor charges to 5 sub M plus 5 sub DC minus 5 sub D. 10 plus 3 minus 0.7 equals 12.3 volts. During the negative half cycle, the diode turns off. Output equals -10 minus 12.3 equals -22.3 volts. Output range from -22.3 to -2.3 volts. The entire waveform sits in negative territory. Mirror image of example 5. Peak to peak 20. Example 7. The last variation. The diode points up. Bias 5 sub DC is on the ground side, opposing the diode's natural conduction. The diode conducts during the negative half cycle. The clamp level is minus the quantity Vi sub DC plus Vi sub D, which is -3 minus 0.7, equals -3.7 volts. The capacitor charges to Vi sub M minus Vi sub DC minus Vi sub D. 10 minus 3 minus 0.7 equals 6.3 volts. During the positive half cycle, the diode turns off. Output equals +10 plus 6.3 equals +16.3 volts. Output range from -3.7 to +16.3 volts. Peak to peak 20 volts. 5 examples, 5 different positions on the y-axis. Let us look at all 5 examples side by side. Example 3 sits from -0.7 to +19.3, the baseline with no bias. Example 4 sits from -16.3 to +3.7. Bias pushes the clamp positive, but most of the swing goes down. Example 5 sits from +2.3 to +22.3, entirely positive output. Example 6 sits from -22.3 to -2.3, entirely negative output. Example 7 sits from -3.7 to +16.3, mostly positive with a small negative excursion. 5 completely different output positions, all from the same basic clamper skeleton. The takeaway: by choosing the diode direction and the bias source polarity, you can place the output anywhere on the y-axis. And no matter where you place it, the peak-to-peak voltage is always preserved. In the next lesson, we introduce a different device with its own clamping behavior, the Zener diode.